Hello everyone, welcome to the Net Online. Thank you guys so much for joining us. We're going to kick things off as we always do with a short video clip that will correspond with our message today. Be sure to like and subscribe so we can give you future alerts for when we post messages, and drop a comment below, and thank you guys so much for joining us.
Here we go. That's fine. Go ahead and scoff. But, there are a lot of things out there that I don't believe in, but that doesn't mean they're not true.
Such as?
Like crop circles, or the Bermuda Triangle, or evolution.
Whoa. But you don't believe in evolution?
Nah, not really.
You don't believe in evolution?
I don't know. It's just, monkeys, Darwin, it's a nice story. I just think it's a little too easy.
Too easy? The process of every living thing on this planet evolving over millions of years from single-celled organisms is too easy?
Yeah, I just don't buy it.
Excuse me. Evolution is not for you to buy, Phoebe. Evolution is scientific fact, like the air we breathe, like gravity.
Oh, okay. Don't get me started on gravity.
You don't believe in gravity?
Well, it's not so much that, I don't believe in it. It's just, I don't know, lately I get the feeling that I'm not so much being pulled down as I am being pushed.
How can you not believe in evolution?
I don't know, just don't. Look at this funky shirt.
Thieves, I've studied evolution my entire adult life, okay? And I can tell you, we have collected fossils from all over the world that actually show the evolution of different species, okay? I mean, you can literally see them evolving through time.
Really? You can actually see it?
You bet. In the U.S., China, Africa, all over.
See, I didn't know that.
Well, there you go.
Huh. So now, the real question is, who put those fossils there and why? Uh-oh, it's scary scientist man.
Okay, Phoebe, this is it. In this briefcase, I carry actual scientific facts. A briefcase of facts, if you will. Some of these fossils are over 200 million years old.
Okay, look, before you even start, I'm not denying evolution, okay? I'm just saying that it's one of the possibilities.
It's the only possibility, Phoebe.
Okay.
So let's pray as we kind of dig in tonight. Lord, we thank you for your presence in that time of worship. We trust you to just come and speak to us. Lord, your word says that your invisible attributes have been clearly seen through what's been made. And so tonight, Father, we want to grasp hold of what's clearly seen through what's been made. God, I pray for anybody here tonight that struggles with maybe doubt or unbelief, or in some way has just kind of been at battle or at siege with the ideas that come at us constantly, sometimes in school and other places. So Lord, we pray tonight there'll be such clarity that it'll be liberating. And we commit this time to you in Jesus' name. Amen. So this part 3, the subtitle, of course the title is Darwinian Evolution, Fact or Fiction. The subtitle is Why Physics and Biology Do Not Support Evolution. So that's where we're going. I'm going to review a little bit because I noticed a number of people here that weren't here last week, or perhaps this is your first night. So I'm going to just back up just a little bit, but we began by looking at intelligent design. And so the compelling statement when we look at even these images are just remarkable. And so when you look at the evidence for intelligence behind the design of what we see in nature around us, it is very compelling. And the question is, why, if the facts and the evidence point toward a designer intelligence, why won't we let those facts and evidence take us to that conclusion? And that's part of the challenge we face today. Even though the evidence is so compelling, the institutional mindset is that, no, that's religion, you can't do that. Even though the evidence itself is religious. That's the problem. The scientific evidence itself is religious by nature because it points to God. It points to a creator. So, and then we looked at the two-model approach, meaning that in science they use a lot of times the word predictions, meaning if you have a theory, you have a hypothesis, so if it's true, if this is true, then we should see these things as a result. And so we all have the same body of facts to deal with. In the end, what we're really looking for is which, in the two-model approach, in this case, the two models would be creation and evolution. And the question is, which one best makes predictions that fit the real world? Which one is the most substantiated? Which one makes the most sense in light of what we actually see in the real world? And I believe that the creation model is far more compelling than the evolutionary model, as you've already been able to see as we've gone through this. So one of the often frequent places that people, just like in that clip, is the idea that the fossil record is somehow compelling us to believe in evolution. And so there are four really big problems with the fossil record, and we spent a good amount of time on this last week, so I don't want to go there too long, but basically you have the abrupt appearances within the fossil record of trees, fish, reptiles, and mammals, and a lot of other things with no predecessor, with no prototype leading up to those. They just suddenly appear complete and ready to go. So there's no transitional fossils leading up to them. They're abrupt. The record is very abrupt. It's very sudden. And so the second thing we looked at was the prediction of the evolutionary model, and Darwin does a really good job. I have his book right there. He does a really good job explaining what the prediction of his model should be, and that is that you should find, over time, eventually, fine gradations of fossils which show the transitional process, going from, whether we're talking about, in the case that we hear all the time, going from a theropod dinosaur, a three-toed dinosaur, to a bird, then you should find within the fossil record many, 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 many transitional fossils. And we talked about that. It's not just about finding one odd duck or one weird bird. It's about finding an overwhelming sense. The prediction of the model is that you should, if we're talking about millions and millions of years of preservation of species and fossils over a lot of time, then you should see a representation of these transitional creatures. And they're really, the fact that they get so excited when they find one that they think, this might actually be one. We may have actually found this weird thing and it's got to be a transitional. The fact that they get that excited over one fossil tells you that the prediction is not met, because they should be everywhere. They shouldn't be hard to find at all. The third thing in the fossil record we looked at was out-of-place fossils. And so this is a really big deal. And so we looked at the bird chain, the whale chain, the horse chain, the man series, all these different series that we have thrown at us all the time as evidence for evolution, supposedly. The problem with all of these, the four that I just named, these are the four that are thrown at us the most often. And so in every single case, there's a problem in the fossil record. The fossil record simply doesn't support it. So in the case of the dinosaur to bird, and of course now it's becoming confusing because they're actually calling birds dinosaurs. And so if you find a fossil that's actually a bird in China, and you got to wonder about those fossils they find in China. I'm telling you, they concoct some stuff over there. It's really strange. They'll mix fossils together and create creatures. And National Geographic got burned big by that. But so if you have the little dinosaur on the left and he's transitioning into a bird eventually, the problem is if you find a bird fossil deeper than the left-hand fossil, in other words, you find maybe multiple fossils of birds, and within the strata, within the rocks, you have deeper and deeper and deeper as older and older and older. So you find the bird fossils way deeper than the theropod fossils by many millions of years by their recording, by their own their own prescription. They're already saying this. There's no dispute about this. The fact is the birds are found deeper. In fact, what we should be saying is that theropods must have evolved from birds. It should be just the opposite. So the fossil record does not support this chain at all, and that's the case with all of these. The problem is the advanced forms, the same with the horse, and that the advanced forms are found too deep, and they end up being contemporaries with the earliest predecessors. And so in that case, that's why we call it contemporaneous fossils. It's the problem of out-of-place fossils. And then we did touch on it a little bit, and I'm going to touch upon it extensively when we talk about age of the earth. But the remaining soft tissue that's found in fossils of all different types, not just dinosaurs, that's the famous ones, but soft tissue found in fossils that are in the entire rock strata, from the bottom all the way to the top, you find these soft tissues. And so that is quite a problem from a deep time perspective of the rock record. So there you have it. That's the problem with contemporaneous fossils. To explain this, the evolutionists they honestly do have a dilemma with this, because the evidence is so much in our favor and showing the gaps and the lack of transitions that they had to come up with a new idea. And the new idea is called punctuated equilibrium. Stephen Gould, he's deceased, but a PhD Harvard paleontologist, a number of years ago, recognizing this dilemma, came up with the theory. This is how it could happen. And it became codified. You see it in the encyclopedias, you see it everywhere, and it's this ridiculous theory, but they put it in they frame it in these very sophisticated terms to make it sound plausible when all they're doing is relating an idea or telling a story of how the implausible becomes plausible. The implausible meaning that they know they have gaps, they know that their transitions are missing, they know that the evidence is missing, so now we have to come up with a way of explaining the absence of evidence. And that's this theory called punctuated equilibrium. These are actually quotes from encyclopedia. The first one, the most direct proof of evolution is furnished by the science of paleontology, or the study of life in the past through fossil remains. That's on page 158 in the Grolier Encyclopedia. And then you go a little bit further in the Grolier Encyclopedia and you find this statement contradicting the first one. Okay, significant evolutionary changes instead are concentrated into geologically brief periods or punctuations, during which the lineages actually split or branch. Under this hypothesis, known as punctuated equilibria, the apparent gaps in the fossil record are actually a faithful rendition of the evolutionary process. Okay, so you follow that. They're acknowledging that they have a serious problems with the gaps in the fossil record. They're huge, gaping gaps. And so they're saying this would explain it. In other words, that evolution happens in fits and starts. It happens in these sudden explosions, and they're not even recorded in the rock record because it happens so quickly. And so now all of a sudden we're really making up a story here. They're really grasping for straws. So that was just to dovetail from where we were last week talking about the lack of evidence in the fossil record. They acknowledge the lack of evidence too. If you end up talking to somebody and they won't admit that they're missing the transitional fossils, they won't admit that there are gaping gaps in the fossil record, they either are ignorant or they're not being honest with the facts. But at least this paleontologist was honest with the facts in admitting that, yeah, we've got a serious problem. Okay, so let's look at physics. So the prediction of physics, of evolution, should be in the past we should have worst expressions of life. We should see things more flawed, and then over time we should see an improvement. But in fact, from the creation standpoint, things were made in the beginning at the best that they've ever been, and then there's been deterioration and breakdown since then. And so our model of creation matches physics much better, because physics really makes a prediction that we should start with the best and lose quality over time. And so we'll see that it's in the second law of thermodynamics. Now this law, and I realize this is kind of nerdy for some of y'all, just stick with me because you're probably going to have children someday that are really nerdy and you're going to need to remember this. Okay, so the second law of thermodynamics is also called entropy. And if you can just think of it this way, what it means is that everything by itself, if left to itself, is falling apart. Everything is falling apart. My dinosaur bones back there, my models, they're falling apart. They get worse and worse every year. And so, in fact, this year I said, well, maybe we shouldn't even use them again. And they said, no, we'll remake. We'll go and, one of the guys has a jigsaw in his shop. He says, no, we'll remake some of the parts that we need so we don't have to give up the dinosaurs and have a bonfire. And I'm like, okay, y'all make some new parts. That's great. But the problem is the second law of thermodynamics. Over time, our dinosaurs are getting weaker and they're falling apart. And that is the way it is with everything. Here you have cars, automobiles. At one time, these were all beautiful, brand new cars on a showroom floor somewhere. And now look at them. And the car you own will one day be like that. Or they'll sell it to Mexico or something, and then eventually it'll be like that. The fact is, the day you drive that car off of the showroom floor, it's worth what? 20, 30% less because they already know it's falling apart. That's the dirty little secret about that brand new car you buy. It is entropy. It is the second law. It's one of the most predictable laws. A physicist would bet his life on the predictability, reproducibility of this law of physics. And so the second law of thermodynamics often is referred to as the second law. It's very important. So the Bible references the second law of thermodynamics on multiple occasions, and it's so precise the way it says it. I always love it when you read a section of the Bible and realize it's touching on science very directly. You think, how did the ancients understand some of these processes? But here we have it. The first reference we'll look at is Romans 8. It says, for the creation was subjected to futility, not willingly, but because of Him, that is God, who subjected it in hope, because the creation itself also will be delivered from the bondage of corruption. The bondage of corruption is the second law of thermodynamics. It will be delivered into the glorious liberty of the children of God. For we know that the whole creation groans and labors with birth pangs together until now. So it's describing this corruption, it's describing this groaning that's taking place in the created world. And then Psalms 102 says it so well. Of old you laid the foundation of the earth, and the heavens are the work of your hands. They will perish, but you will endure. Yes, they will all grow old like a garment, like a cloak. You will change them. In other words, the earth, the universe is wearing out. It's running down. It's losing energy over time, and it ends up what they call entropy. It's all being subjected to entropy, meaning that energy is being lost, not gained, and it's all basically falling apart. And the Bible corroborates that. So people tend to think that when they look at the past, or they look at hominid fossils, and they look at these things, over, deeply buried or whatever, or even if you go back to the Ice Age and some of these areas, they dig up these fossils, and they make the assumption, and we make the assumption, that these people are less intelligent than us. We think that they're somehow, because of evolution being so deeply indoctrinated within us, we have this idea that somehow we are the smartest of all. We're the pinnacle of all of humanity. And so therefore, everything in the past is somehow handicapped with a lack of evolution, when it's actually just the opposite. So in the past, you have, if you look in the rock record, you look deep into the fossils, you'll see bigger and better. You see dragonflies that have wingspans like this, maybe bigger. How about having one of those get in your church during a meeting? That would be pretty exciting. Or how about roaches that are about this big? They must have had a very important purpose, ladies and gentlemen. I know that you disdain them. the insecticide people came to our house today because of things like these roaches. But the fact is they were bigger and they were better, and a lot of the animals were bigger and a lot of them were better in that sense. But if we look at human beings, I've mentioned this, I think, in part 1 or part 2, but that man's intelligence in the past does not really show evidence of diminishing. In fact, and I still, you look at Stonehenge, you look at ancient Egypt, you look at a lot of the ancient maps, it looks like that they could fly. I don't know how, I don't know if they had hot air balloons or what they had, but some of the maps, the ancient maps that were drawn, gives you the impression that they had an aerial view to be able to draw them the way they did, as accurately as they did. I mean, really a long time ago. And so you look at this and go, well, these were not dumb people. I mean, even if you look 2,000 years ago at the irrigation and plumbing of Rome and the layout of the cities and the urban planning and all that, and you think, well, these people are just like us. They just haven't developed all the technology we have. But Plato refers to the technology lost in the flood. That there was a whole kind of gamut of ancient technology that was pre-flood that's been lost. And so we've had to regain and rebuild and all that. So a lot of things have been lost over time, not because of evolution. So Stonehenge is supposed to be this astronomical, it's supposed to be coordinated with astronomy in this most profound way. I've watched programs on it. It's absolutely phenomenal. The Egyptian pyramids, and even in Israel, even in Jerusalem, they have some of the foundation stones of the temple are still there, right? And these things are like, I don't remember how big they are. They're like 20 tons, 50 tons, and they have a perfect seam, a perfect straight edge seam, and there's another one right on top of that one, and they have these magnificent stones, and you're going, what? We still can't really quite figure out how they were doing it, but they were doing it. It really is mind-boggling that we can actually have our hands on a pyramid, look at its design, look at the blocks, look at every piece of it, break it down, go inside it, and cannot figure out really and truly how they did it. Apparently Moses was privy to some of that. If you watch the Ten Commandments, he was out there designing pyramids and stuff. The movie, The Ten Commandments. All right. Okay, so then you look at extinctions. Extinctions, it means that we have less species now. We have less creatures. We have less diversity now than we had 100 years ago or 200. Not just because man kills off animals. It's because nature itself selects them for extinction. The dodo bird, yes, the poor dodo bird they were such easy targets, and yes, mankind did kill all the dodo birds. I wish we still had a couple of dodo birds so we could look at these birds. But the fact is that yeah, there are some extinctions that have happened because of us. But the vast majority of extinctions have occurred on their own just as a process of nature. All you have to do is look at the rock record and see extinctions that you can't even count the number of extinctions. And so, but what you don't see is the rise of new species through evolution. Ever. You just, when is the next headline in the newspaper? We have just had the arrival of a new creature, a new kind of animal. But what we do have are extinctions. So we have a breakdown, we have a loss of energy, we have a loss of order, we have the second law of thermodynamics. The complexity of language is lost. Do you ever read things from, say, 200 years ago? Read documents from the founding fathers and the way they thought, the vocabulary they used. And so, but that's typical. So over time, what happens to a language is it breaks down and simplifies over time. It becomes less complex. It becomes less powerful in a lot of ways. That's the idea of entropy. In other words, things break down over time. Relationships break down over time. If you have a marriage, and this is, a physicist wouldn't say that this is the second law of thermodynamics. But what I'm showing you is a universal pattern. That if you have a marriage, you have a husband and wife, and they put no effort into that marriage, they put no kindness and love and tenderness and attention given to that marriage, over time, the couple will grow apart and they'll find new interests and they'll begin to separate. And 10, 20, 30 years later, they don't recognize each other anymore, and they divorce. So in other words, to maintain a rich and good marriage means that you have to be committed to maintaining effort, of inserting and investing effort into that relationship over time so that it's preserved, so that it holds together. But if left to itself, it will fall apart. That's the idea. So when we get to life systems, like systems of biology, does entropy affect systems of biology? And your guess is probably, I'll bet it does. And the fact is, it does very much so. And this is going to lead us to understanding better the role of mutations and natural selection, which we've already identified as the mechanism that evolutionists must have. I don't know if anybody remembers, but why are mutations so important to the evolutionary model? I can't have that conversation, although somebody here probably could answer it. Why mutations are so important to the evolutionary model? It is because the evolutionary model, to be able to go from, say, a theropod to a bird, or from a dog-like creature to a whale, or any of these types of transitions that they portray and they identify, requires new information. It requires new genetic information to be able to create or to be able to develop those types of improvements in a creature. And so it begs the question, where does this new information come from? Are mutations an adequate method of bringing new genetic information? Because a mutation can bring new genetic information to a biologic system. So when we look at biology, do we have a case for a natural means of creation or of evolution, or do we have a supernatural means of creation? And I believe the creation model is the only model that really works here, because there's no better explanation than God created the complexity, because He had the information and then imparted it. When you look at the DNA, we looked at the cell, design of the cell, the nanotechnology, all of this intricacy within the cell is just absolutely phenomenal. It's stunning. So for macroevolution to occur, remember we talked about macro and microevolution, but for macroevolution to occur, that would be, for instance, going from one kind of animal to another entirely different animal. It would be going from a theropod dinosaur to a bird. That would be macroevolution, two entirely different types of animals. So for it to occur, new genetic information must come from somewhere. And so without God in the mix, the only source of new genetic information is a mutation. And I'll tell you right now, that is a pretty sad scenario for the evolutionists. I'll explain why. So if mutations are the only source of new information, and maybe you're going, what in the world is a mutation? I've heard the word. I know that teenage turtles are mutants. I know that, you may have seen a lot of movies where they say you get the idea that a mutant is some kind of deformed deformation, right? So a mutant, we might have one in the room. I mean, you could be a mutant. I mean, is anybody here double jointed? I've seen people do crazy things. They'll take their arm and bend it backwards, and you're like, oh, whoa, are you double jointed? Can you show us? Show us your mutation. Oh, it's a finger? Here, stand up. Let's see it. Hold it up here. Oh, let's see. Ooh, that's wicked. Really? Okay, so are these positive mutations? See? So they're not going to contribute to your survival and your children's survival someday? You can do what? Oh, her fingers were wicked looking. It could come in handy, somebody in a dark alley and you just go like, yeah, freak them out. So mutations are basically a genetic accident. So I have the picture here. How many toes on each foot? That's an example of a genetic accident. And you have a frog here with, 6 eyes? And so natural selection will act on that mutation to say, okay, that mutation is so positive that it's going to contribute to that animal's survival. And this is evolution. Then the mutation occurs, natural selection comes along, just nature, the process of nature. And so an example of natural selection, it's a great illustration, bottom right. You have 2 birds, the one with the longer beak has a better chance of getting the worm in the tree because it's got a longer beak. So that means natural selection will probably favor the bird on the right for survival. Right? And so natural selection is a very real thing, and we see it often. I was telling you guys about if you're a brown rabbit in snow, your chance of survival is not good. Natural selection will not be kind to you. But if you're a white rabbit in dirt, you probably aren't going to do well either. So natural selection will change the mix and the balance of white and brown rabbits, respectively, see? And so if a mutation occurs, natural selection comes along and says, oh, we have somebody, maybe there's somebody here tonight that has webbed feet. Maybe if we become a very aquatic, maybe the continents flood and all of a sudden you go, well, I'm going to survive better than all of y'all because I have webbed feet. And so all of a sudden that would mean the rest of us would die and you would survive because of webbed feet, and you'd have children that are webbed feet children. And so therefore the human race changes. Natural selection acts on your webbed feet, and now we have more webbed feet people. Okay. I mean, that's stupid. I mean, it's a really stupid example, but I'm trying to kind of reduce this down so that everybody can kind of, okay, I think I see how it works. So I have a clip for you, and this kind of illustrates how we are indoctrinated, and it's kind of funny, but we hear all the time in movies and different things where people are exposed to radiation and they get superpowers and they get all kinds of special abilities because so this is one of those clips.
Hi.
Oh my God, I'm dead.
It's okay.
Oh no, I'm dreaming. I must be dreaming. Okay, now those guys in the black pajamas, they jumped me. And that rat, I saw you in the parking lot. That explains you. And you guys, I have no idea where you came from.
If you will please just sit down and calm yourself, I will tell you where we came from.
Talks.
It is really quite simple, Miss O'Neill.
And he knows my name. Perfect.
15 years ago.
Why don't I ever dream of Harrison Ford?
For 15 years now, we have lived here. Before that time, I was a pet of my master Yoshi, mimicking his movements from my cage and learning the secret art of ninja. When we were forced to come to New York, I found myself for the first time without a home, wandering the sewers, scavenging for whatever I could find. And then, one day, I came upon a shattered glass jar and 4 baby turtles.
That was us. Shut up.
Oh, no.
The little ones were crawling into a strange glowing ooze from a broken canister nearby. I gathered them up in an old coffee can, and when I awoke the next morning, I received a shock, for they had doubled in size. I too was growing, particularly in intellect, and I was amazed at how intelligent they seemed. But nothing could have prepared me for what happened next. One of them spoke.
Pizza! Pizza!
More words followed, and I began their training, teaching them.
So So this exemplifies this whole idea that permeates, especially movies and TV shows and so forth, that if you get exposure to uranium, some sort of radioactive ooze or something, that somehow you'll get all kinds of added benefits. Mutations as a result of the radiation are improving, but does that actually have any bearing on reality? Wild guess in the left-hand side. Wild guess, they're saying no, it has no bearing on reality, and that is correct, has no bearing on reality. So you guys are understanding that the mechanism of evolution is mutations plus natural selection given deep time. That's why we have to have billions of years, because they already know this. There's no plausibility to this unless you have billions of years. Hang on, buddy. All right, so. Yeah, the Ninja Turtles are real. Okay. Oh, the Ninja Turtles. Okay, I'm sorry, Daniel. I realize you won't sleep tonight. Find out the Ninja Turtles aren't real. All right, so he obviously grew up with them. Okay, so the genetic mistake or mutation must contribute toward the survival, or that is natural selection, of the organism, or evolution cannot occur except in retrograde. Retrograde meaning that an animal or creature can lose information and kind of change its nature. So if you have, say, an ostrich that maybe in the past had bigger wings, and over time it doesn't use those wings, and over time it loses that genetic information. That'd be an example of retrograde evolution. So what we're talking about now is genetic entropy, second law of thermodynamics. In genetics, genetic entropy is a mutational meltdown in which the genome of any population accumulates deleterious or destructive mutations more rapidly than beneficial mutations. This accumulation of destructive mutations within a species can lead ultimately toward extinction. So what this is saying is that the second law of thermodynamics also works in genetics, and that what we're seeing with mutations and natural selection, what we're seeing is not evolution. What we're seeing is the opposite of evolution. We're seeing a breakdown, we're seeing deterioration, we're seeing entropy. Does that make sense? So everything they're telling us is smoke and mirrors, that somehow evolution is occurring, when in fact it's just the opposite. And everybody's hearing this stuff and just nodding along and going with it, but it's all we have been lied to over and over and over again, telling us that this is somehow plausible when it has no plausibility scientifically. Now, I'll give you a great example. The poor fruit fly. I know you love fruit flies. But the beauty of a fruit fly is it has a very short gestation period. It's a very short lifespan. So they took 100 years of laboratory attempts to experiment with fruit flies. So what they could do is create, say, 3,000 mutations in the fruit fly. In other words, it would represent millions of years in a short amount of time. And they would use radiation, other things to afflict the poor fruit flies to create kind of deformities, mutations. Mutations essentially are deformities. And so the fruit flies, so what did we see after 100 years of laboratory attempts to observe mutations in the fruit flies? Did we ever see an improved fruit fly? And we're simulating millions of years of evolution artificially in a laboratory. And so what did they see? See, here's the poor fruit fly. He's looking through the daily, what does it say? That. Oh, anyway, it's in the personals, it has here what he's looking for. He's seeking a female fruit fly, a short-term relationship. He enjoys romance and fermentation and long walks on the peach. So anyway, the fruit fly is in a real dilemma. So who knows how many of them were sacrificed in these horrible experiments. Thousands and thousands of fruit flies, many thousands of mutations. So what would happen is they would create these mutations that they would begin to deviate too far from their original design, if you will, and guess what happens to them? They become sterile. So they can't reproduce anymore, so they're at a dead end. They would have all kinds of mutations. Some of the fruit flies would have no wings, some would have no eyes, some would have extra wings, some would have small wings, curled wings, extra legs. They created lots and lots of mutations, but what they discovered was that none of these mutations in the end were really beneficial. In fact, some of them may have been neutral. Maybe the fruit fly is fine, but he's weird. But in the end, the fruit fly, the vast majority of the mutations were harmful and detrimental to the fruit fly itself. So they did not prove, in fact, what they proved was that evolution is not happening by using the fruit fly. They could not simulate evolution. Their hope was that they could actually demonstrate evolution. And in fact, what they did is demonstrated the exact opposite. So here's the dirty little secret under the hood. When you really look at mutations and natural selection, this is the truth. John Sanford, who's a PhD geneticist, he quantified the ratio of harmful to beneficial mutations. You never read this anywhere in a textbook. You never hear it in genetics. You never hear it in biology. It would be shocking if they actually did, because it so undermines the whole entire evolutionary model that it's just you can see why they essentially censor this information. But so here's his calculations as recorded in one of his books where I found this. He says there are 186 beneficial mutations versus 453,000 harmful or neutral mutations. Very few were neutral, by the way. They're mostly all harmful. The ratio of, in other words, in English, it would be 4 beneficial mutations out of 10,000 mutations. That's not very many, ladies and gentlemen. 4 beneficial mutations out of 10,000 harmful, destructive mutations, meaning that, in other words, any creature, the more mutations it have, and we all know this, it's not like, you're going to have a baby and you go, oh my goodness, I can't wait to have this baby born and see what mutations we're going to get. I mean, that's like every parent's worst dread. It's like a classic. The first thing you do when that baby's born, and Shaylee will do it, and Josh will do it, and you're going to go, how many toes does he have? Or is it she? It's a he, another he? Okay, that means you just have more kids until you get some girls in the mix. We got a lot of boys coming in here. Okay. So the first thing Josh will do, Shaylee won't, because Shaylee will go, I will love my child regardless. I don't care how many toes it has. We'll just cut off the extras. Okay, so, and that's what they do actually. And so he goes, 5 toes, no mutations, what a relief. And so like we said, some of you have some harmless mutations. But the fact is that we all know instinctively that mutations are bad, and we don't want them. They are detrimental. And we know that. We know it instinctively, but we also know it by the data. That you have 4 beneficial mutations out of 10,000, meaning that there are thousands and thousands and thousands of bad mutations, which are harmful to the survival of that species. Does that make sense? So how are mutations creating evolution? How are mutations creating a benefit when in fact mutations are entropy? They are actually part of the breakdown of the integrity of that creature, or that human, or that monkey, or whatever it happens to be. It is an insufficient mechanism for evolution. So, one of the things you hear a lot, we'll look at the chimp and the human. Chimp versus human. How many of you heard it? We have a genome that's 98% similar to a chimp. And it sounds compelling. That means, wow, we must be related. That chimpanzee must be my cousin. And we do experiments on them. How cruel to do that. It's obviously not really an animal entirely. It must be one of our cousins. And so because you look at the genome and you go, wow, they're so similar. So let's just clarify that a little bit. And so what I'm going to do is give you a what if the genome is 90% similar to human. The genetics have an overlap between chimps and human beings of about 90%. And this is presuming that we have a chimp-like ancestor, like Amphorensis africanus, or one of those, Lucy, for instance, was kind of a chimp-like little animal that they say walked upright, but it had knuckle-dragging hands. So that Lucy was really just a chimp. Okay. So the evolution from primate to human, 5 million years, requires, here's what's required to bridge that gap. 150 million nucleotide changes in 250,000 generations. Now follow carefully. I know you know what a nucleotide is, right? They're the structural units of RNA and DNA. So it would require this for each generation, 250,000 generations in 5 million years, it would require 600 beneficial mutations per fixed in each generation. Now, y'all following that? Anybody multiply it yet? 600 times 250,000. Okay, so I want to make sure y'all follow this. So you have 250,000 generations between the chimp-like ancestor and a human. In those 250,000 generations, each generation requires 600 beneficial mutations. We already saw how hard it is to get a single beneficial mutation. We already saw that you're going to have 99% of all the other mutations are going to be harmful and detrimental. But nonetheless, in theory, let's just say we can pull it off. 600 beneficial mutations for 250,000 generations of monkey-like beings becoming human. Anybody calculate it? What's 600 times 250,000? So you have to have 150 million beneficial mutations, and they have to be in the right order, in the right sequence. Whew. Okay, so, but the fact is, that's assuming that it's a 90% similar homology or genetics genome. And the fact is that studies have been done to show it's not really even 90%. It's more like, here's a quote from a Dr. Jeffrey Tompkins, PhD geneticist. He says only 69% of the chimpanzee X chromosome was similar to human and only 48% of the Y chromosome. Genome-wide, only 70% of the chimpanzee DNA was similar to human under the most optimal alignment conditions, which means that the number we just came up with, 600 times 250,000, would have to be maybe 2 or 3 times that number. It's much worse than the scenario we just mapped out. Okay, you following? I want you to understand how many we may think, oh gosh, you know, there's a lot of similarity. Maybe it's not that big of a jump. You start realizing from a mechanical genetic standpoint what has to happen to go, say, from a theropod to a bird, how you develop flight, what are all the mutations necessary to do that, to develop. And so I have a quick clip. I'm going to show you what's required. Remember we talked about the whale and how you had the dog-like creature they say was the predecessor of the whale, the ancestor of the whale. And so he's going to show this is how many things would have to evolve in a whale from a terrestrial animal.
To even have a basic fully aquatic whale in and of itself is a feat of engineering. I'm not saying intelligent design, I'm just saying engineering. What do you need? You need a countercurrent heat exchange because the testes are inside the body. You need a ball vertebra. Why? Because unlike a dog's tail that wags from side to side, you have to have a tail that moves up and down. You have to have the tail flukes. They're not found in the protocetids, they're only found in the fully developed aquatic whales. You got to have the musculature for it. You have to have the reorganization of kidney tissues. Why? Because you're not drinking fresh water. You have to intake salt water. You have to nurse young underwater. You have to modify the mammary glands for that. The orientation of the fetus of, for example, the protocoets, the so-called intermediates, we know were like those of terrestrial mammals. However, in the case of whales, the orientation is reversed. You get reduction of the hind limbs, forelimbs transformed into flippers, hydrodynamic properties of the skin, special lung surfactants. When whales dive and they come back to the surface, the lung has to re-expand and it has to do so very quickly. Novel muscle systems for the blowhole, modification of the eyes, modification of the teeth, and it's on and on. So what do you have? You have, in a short window of time, hundreds, if not thousands, of character state changes. Dramatic reorganization. Now, my question is very specific. Can this geological pattern that I accept and that I'm not going to attribute to outside intervention of any form, can this geological pattern, this progression of forms, be explained by the processes of population genetics? And there, in other words, does neo-Darwinism, and just neo-Darwinism, provide an adequate causal explanation for the origin of these structures? Well, what is neo-Darwinian evolutionary theory? It's essentially that mutations generate variation. There are different kinds of mutations, different frequencies. Natural selection preserves the successful variants, and therefore, if new traits are necessary to produce a different biological form, depending upon the number of traits, then it's assumed that you have many adaptive mutations that had to arise and had to be preserved.
Maybe that makes a little bit more sense as I kind of went through the mechanics of how you would actually bring in new information. And so basically, when we get down to it, you just have to look at the whole thing and go, the emperor has no clothes. There's nothing left. They don't have the fossils. They don't have the biology. They don't have the genetics. There's just really, they don't have physics on their side. Physics is saying the opposite of evolution. It's breaking things down. And you start looking at the whole thing, you have to step back and go, they have really been lying to us. They've been lying to us constantly and a lot, and indoctrinating children to really toward atheism ultimately. And it's really tragic that we have this occurring in our country. I think it's interesting, the state of Texas is very close to passing school vouchers. You realize the Senate already passed it. The House still has to be a harder battle in the House. But it's interesting because what that would do is it would create massive competition for the public schools. And that's why I'm for it. Because this monopoly that they've had, centers of indoctrination are relentless. And so many people can't even afford to pull their kids out of public school. And so this would create, who knows how many new schools would arise, and you'd be able to pick, and it would be competitive, it would be more capitalistic, and it would be extremely, I believe, successful in the end. It's something we desperately need, and to save a generation of children. So, I have good news for you. We actually share 50% of the DNA with a banana. And we share 60 to 75% of the DNA with chickens. So that means we must be related to bananas. It's absurd, I know, but that's how absurd some of these arguments are. The argument of somehow that the similar genome is somehow indicative of evolution. It's really not. They have nothing. There's nothing there. Let's look a little bit at laws of heredity and genetics. Gregor Mendel, who was also a Christian, he was a monk. He did a lot of experimentation with peas and gardening, and he found that he could reshuffle the genetic information that's already there in the plants he was planting. And he did selective breeding. And there was no new genetic information brought into it. It was just a matter of genetic variability. Like a deck of cards, you got all the genes, you got all the genetics, you got a deck of cards, you move them around, reshuffle them, and guess what? Oh, we got this over here. Oh, we've got this. That's what they've been doing with our fruit for a long time. So grapes now are like sugar bombs. They're like these beautiful creatures full of sugar. But that's not how they've always been. They've genetically modifying them so that we want them and we'll buy them and keep buying them and get addicted and hooked on the sugar. But anyway, thank Gregor Mendel for that. So Jeanette, for instance, my wife, she has siblings. There are 5 kids, and they are all different. There's some blonde kids. There's brunette. She's brunette. There's some with brown eyes. She has brown eyes. Some with blue eyes. They're like, some of them are like Dutch people, which they're all Dutch. But she's like a dark Dutch, maybe from the Spaniard side. Maybe a gene snuck in there and she's not even tall. If you see, the Dutch women are the tallest women in the entire world. If you go to some of those cities where they exist, you see the Amazon women. Madeline, you would be at home. You would find these are my people. I have found them, and I mean, you would blend in. You wouldn't be special anymore now. See, right now you're like special. But so we would look at it and we would speculate and go, well, we would look at Jeanette's mom and we go, how did all these children come from the same litter? If anybody was cheating, it would have had to have been her because she birthed them all. And we knew she didn't cheat. We thought, well, look at them. Look at these kids. So it was a reshuffling of the cards in the deck. And so Mendel found that there were essentially reproducible formulas, mathematics and probability that you could reshuffle the cards and create predictable outcomes. Pretty amazing. But that's where we're looking at Darwin's finches, which are thrown out there all the time as example of evolution. How many of y'all have heard of the Darwin's finches in the Galapagos Islands? I mean, who has not heard about it? Really? Okay. Not very many, but this is heralded in probably every biology class you would ever take. They're going to talk about these finches. And so Darwin observed them, and he noticed that depending on the change in the weather, that the finches that certain ones with certain beaks would become more dominant and the others would fade out. And so he's observing natural selection, that some of the finches were favored because of a change in the weather and the patterns. And so he's saying this is evolution. We can tangibly observe it happening. Well, what it is really, it's just the adaptability, the variability within a species that allows it to change and to survive. And then, so what we find out in 1983, the El Nino came through Galapagos Islands, rearranged the whole weather pattern, and guess what? All the finches went back to a simple hybrid like they started. It just reversed everything. But here's what you have to remember, and this is, again, using microevolution to build a case for macroevolution, and it doesn't really pan out. As we talked about with the fruit flies, you take it too far and it becomes sterile. And so the El Nino changed it all, and so what we find out is, guess what? They're all still finches. So remember, microevolution versus macroevolution. Genesis 1:25 describes this. God made the wild animals according to their kinds, the livestock according to their kinds, and all the creatures that move along the ground according to their kinds. And God saw that it was good. And so in our model, the evolution that we do believe in as creationists is we believe in the microevolution. If we see that, the tree versus the orchard is a great way to portray this concept. The tree versus the orchard. The tree is the line of common descent from a single organism, and the Friends clip explained that quite well. You don't believe in evolution? So the orchard is what we believe in, that you have a great deal of variety that stems off and branches off, but within a kind. And a kind can be a very broad group. It might be more like what we would say in biology, maybe more like a family, or maybe just subfamily. So that would be a biblical kind. And so Louis Pasteur was a very committed Christian. He's a brilliant scientist. He's considered one of the greatest scientists. And he got a lot of grief over his views rejecting evolution. He rejected Darwinism. And he was a minority, but he had other scientists that joined with him, and they stood their ground. But what he did is he experimentally disproved what was referred to as spontaneous generation at that time. I'm changing topics a little bit. So once and for all, it was established that you can't have life derive itself from non-life. So for instance, they thought maggots came from meat when in fact it didn't. So he proved it, remember the jars and the covers, and showed that maggots actually were fly eggs and that they didn't come from the meat. And so he established what's called in every biology textbook, it's heralded as one of the laws of biology, the law of biogenesis, and that is that life only comes from life. And even, you could even say it even further, like life only comes from similar life or like life. Life comes from life, period. That's it. It's a law. That means it's reproducible. That means predictable. And anything outside of that is rejecting the law of science, which is now uncontested. So this idea of spontaneous generation, though, seems to have come back. And in the name of evolution, in the name of atheistic origins, well, apparently life can come from non-life, even though biogenesis is heralded in every textbook, probably in the world. So in the biology textbook, this was used until 2006 actually, and it's going to remain similar. I have a new biology textbook, but it would have taken so long to find all this there. In that textbook, it says biogenesis, the idea that living organisms come only from other living organisms, then became the cornerstone of biology. That's what it said in that textbook. It also says this on page 424 in the same textbook. It says, a modern theory of evolution is perhaps the most fundamental concept of biology. Here they're saying that evolution is a fundamental concept, but they just said biogenesis is a cornerstone. Biogenesis is a law of science. There's a big difference between a law of science and a hypothetical or a theoretical or a theory. The Miller-Urey experiment, maybe you've heard of it, it's this ridiculous experiment where they supposedly, and this is plastered everywhere, we have an example of life coming from non-life. So you're trying to tell us that the law of biogenesis is canceled because you create this laboratory simulation? And so Urey created this whole concocted thing to supposedly come up with an amino acid or something, and so obviously they're imposing intelligence on the whole process. They've got test tubes in a laboratory and they're trying to concoct this thing like it would happen in nature that way. But they never really did. And so the guy, Miller, actually rejected this whole scenario, which is still in the textbooks, by the way. He says, no, I don't think it really came from a boiling cauldron. I think it formed in a freezer. So he's completely abandoned this, and now they're looking at, a freezer or whatever. So in other words, they're all over the map. They have no idea. It's just all a story they're making up. There's no science behind it. They're lying to us. And they make it look like it's legitimate. They make it look like it's actually meaningful, but in fact there's nothing meaningful about it. Let's go back to Louis Pasteur and the law of biogenesis. That is science, and that is provable. That is factual. Embryology is another thing. You probably saw it. I remember seeing it when I was younger. You had the lineup of all the fetuses to show this idea that it somehow reflects a mirror image of evolution. And so Haeckel's, or is it Haeckel, Ernst Haeckel, how would you say that in German? Deceived the world of science for a century with his fake drawings on the top level to show all the similarity. But the actual fetuses look like this from each of those. You have human, rabbit, chicken, turtle, salamander, fish. So these were faked to make it look like they all had a common ancestor. So scientific laws, that's what I'm talking about with the law of biogenesis. And we also looked at, so here are four scientific laws we've referenced in some way or another today. And that is 4 laws of science which all contradict evolution. These are laws of science. These are not contested, they're not theoretical, they are reproducible, they are solid science laws. Everybody agrees with them. Number 1, the laws of heredity and genetics, which said that the characteristics of offspring are passed on from the parents according to precise mathematical ratios. Second, the second law of thermodynamics or entropy. Joule and Kelvin, also Christians, by the way. The law of biogenesis, established by Louis Pasteur, also a Christian. And then we have the laws of probability applied to evolution. And so you start looking at the probability that it just becomes an impossibility when you look at the odds, the frequency of mutations that are positive versus negative and all these things, and you start looking at the probability that you would actually develop. So that's what I was actually doing when I said, okay, given 250,000 generations and 600 mutations, and then that's assuming there's a 90% similar genetics, genome and so forth, that we could see this much evolution take place, and really it's just an impossibility. It's just ridiculous. There's just nothing. It doesn't matter how much deep time you allow. It doesn't matter how many billions of years you tag this with. It's just not possible. That's the laws of probability. So Jeremiah 33, I'm going to close with this. Thus says the Lord, if my covenant is not with day and night, and if I have not appointed the ordinances of heaven and earth, then I will cast away the descendants of Jacob and David, my servant. What he's saying is that there are laws. There are physical laws. They have been programmed into the universe, and they are predictable and reproducible. And God is saying that I'll stand by it. God has an order in the universe. Man defies Him. God made you as a human being, as a special act of His creation, and you were made in His very image, the Scripture says. And all of this evolutionary dogma undermines that simple statement. In the image of God, He made them male and female. And by rejecting that, we become fools. And so that's what I had tonight. So perhaps, I wasn't going to do any Q&A until the very end, but if y'all have one or two questions right now, maybe pertaining to the topic, hopefully your mind's not just spinning. It's a lot of nerd stuff, I know. Hopefully you're learning something. Is next week the age of the earth? What are we doing next week? You see, that'll be fun. Are we going to look at, yes, next week we look at the age of the earth and time clocks. That'll be fun. So, Anybody have a question? I don't usually do this. I usually do it on part 6, but just in case. Wow, quiet group. Okay, we got one.
Does the early bird get the worm or the long-beaked bird get the worm?
I'm voting for the long-beaked bird. Wow, that's a really deep question. Man, I'm not sure how to. Anybody else? I mean, this is y'all's chance. So, yeah, okay, Cameron.
So, I heard something the other day about the Lucy thing that you brought up earlier. So, do you know anything about where they found those bones? Have you heard?
I have heard, but I couldn't tell you exactly. I think in Africa somewhere.
Which I don't know what the story is exactly, but I heard I don't know if it's theoretical or if it's factual, that they actually found the bones that they put together to formulate, the skeletal structure. Those bones were actually discovered miles and miles apart. So there's no way they can prove that the bones that what was it, African, what is the scientific word you used? Yes. So, yeah, and I think it's in the Museum of Natural History or the Smithsonian or somewhere like that, and they've got it where she looks like she's got human feet, but again, like all these bones that they used to put it together were found scattered all over the place.
Yeah, I don't know if they were miles apart, but nonetheless, the skeleton that you see laid out is very fragmented. It's very incomplete. And so the entire argument that separates Lucy from a chimpanzee is all about the hip ball and socket joint. And they have very little of that to even concoct. But the actual valgus angle of the hip is actually more like an ape or a monkey. And it has evidence of knuckle dragging. So, So the idea is that, well, because the hip is this way, even though we don't have the feet. Okay, so it is a lot of speculation. So, but a lot of times the bones are spread out more than you think. And are we really getting them all from the same skeleton or not, this kind of thing. And that's why I mentioned this book the other day called Bones of Contention. I don't recall if they deal with the Lucy fossils in here or not.
So we actually did learn about the second law of thermodynamics when we took thermo as in engineering school. So I wanted to ask Daniel what they taught on it, because for us, they always taught the second law of thermodynamics is entropy, and it's basically that as things continue on, they get more disorganized. But then they also mix in heat with it. So I didn't know. That always seemed interesting to me. It's like, why are we studying about how things get more disorganized in a class based on thermo and fluids?
You have any comments, Daniel, about the second law?
Pretty much the same as what you said. I do remember my instructor mentioning how we grow older, not younger. That was about the only other thing. Yeah. To disorder, not to order.
We grow older. So he was applying the second law to human biology. Exactly. By saying that. In other words, aging is a form of breakdown. Yeah.
In the Rock Record talk next week, lecture, sermon.
Oh, you mean am I?
No.
Oh.
In the Rock Record one, do you touch on the soft tissue? Is that when you talk about it?
I will.
Okay.
Next week.
I remember a video clip, and it has stayed with me forever.
Yeah, it's amazing. But yeah, I'm going to spend some time talking about the soft tissue and the implications of that. Anybody taking geology classes in here recently? Anybody? Nobody's taking geology classes? Did they ever talk about the soft tissue in fossils?
No.
Yeah, they're not going to.
But
Did
they
you
do
raise
talk
your
about
hand?
Pangea.
You taking a geology class? Anybody? Spencer, are you taking geology? Did they talk about soft tissue in the fossils? Yeah, they're not going to talk about it. It's disastrous. I mean, the implications are disastrous for the whole standard rock chronology that they concoct. Yeah, Keith?
Are you going to talk about, at any point, these discoveries of more modern, in the scope of history, tools that have been found in rock where scientists would age them at like millions of years?
Yeah, I will. It's a real touch and go there because most of those things can be explained away. Oh. And I have pictures, a lot of them, like the hammer that's in the Cretaceous rock, for instance. There's a number of those that are kind of anomalies, or the pot, the kettle, the black pot found in the coal seam. And the problem with a lot of those, it's not that I have a problem with their being real. The problem is that there's no documentation, there's no in situ record of where it was found and how it was found. It's just all somebody's opinion from 80 years ago. We found this and we were breaking coal and putting it on our stove and out came this pot. Things like that. So there's not much science framework for those supposed alleged discoveries. So that is a problem. I don't know there's a single one that I would swear by it. But I'm intrigued by them. Great questions. Anybody else? Huh? Is what? Oh, okay, Mariah. We'll wrap up. I know it's getting late.
In almost every culture around the world, there is some kind of mythology relating to dragons that are very, very similar. Do you think those are just dinosaurs?
I am going to talk about that. In part 6, I'll give a lot of evidence, sculptures, artwork, cave art, things like that that appear, and really not only that, there's written testimony. Marco Polo, for instance, documents going to China and seeing, and he described a T-Rex. You have to remember, they hadn't discovered the fossils yet. And he wrote a description of a T-Rex that was being used by the Chinese as an animal that was somehow in their captivity. He described the three claws. He described the little arms, the big head. I mean, it's really amazing. So there's a lot of information surrounding the idea that human beings actually have seen dinosaurs and described them, including the Bible. So we'll look at that in more detail. It's a fun topic, it really is. Okay, well, we'll call it a night. I think we're going to have snacks. Can we break out the snacks and snack bar and everybody can hang out? And great, thank you all for coming out tonight. It was a great night.